So let this meeting be officially opened. So a little bit what we will be doing here. I have some news that I have to announce from Build Stuff team, what we are preparing for this year. Later on, we will have a quiz, then we will have Sam Newman's session, and then we will head with Q&A. And this is such a great opportunity directly to ask Sam all the bothering questions that you may have. So first, everyone can see my screen, yeah, I assume?
Yes.
I remember once I was going through all presentation and no one was able to say, oh, your screen is not there. So, okay, great. So first, information about Build Stuff. We just announced a call for papers and we are looking for speakers for Build Stuff 2021. And this year, we will be celebrating 10 years of the conference. And I can't believe that 10 years just flew away so fast. So it will be a very special year personally for me, because that's like 10 years having this career of mine. So everyone who is here, I'm inviting you to apply and to offer your session and to, I believe that you have what to say, you have your daily work. So share your practices and, well, you know, if you will start speaking at Build Stuff, then you will go worldwide. And we have some speakers over here, like who had that experience. So it could be your first step to a huge market. So all information is on Build Stuff website. So, and submissions are open until the 3rd of June. Another thing, so, we just published all the videos from last year virtual conference, and everything is available for free on our website as well. So go in, check it, and you can watch it. And one more thing, we have a special code for Sam Newman's course that will be happening this May, and until Monday there will be additional 20% discount. So we will send a follow-up email to remind you. But if you will want to go even deeper into microservices, so this course has been very popular, and we've been running it for the last I don't know, 2 years, I think. First it was on-site, now online, and we noticed that online workshop was very, very popular. And I'm finishing with all those news. And now we are going to that fun part that I was mentioning, and we will play a quiz. As usual, we have some swag bags, swag from Build Stuff. And quiz is, well, you need to turn on your Kahoot.it and be as much competitive as you can. So the faster, the quickest will win. And of course, the one who will respond questions that we prepared for you today correctly will be the winner. So, but since this is our first meetup this year, we will have 3 winners. And swag consists of Build Stuff t-shirts and all other useful stuff that you can have around your table, around your computer. So now I'm giving my stage for Vaida, my colleague Vaida, who will explain all other rules. Vaida, are you here?
Yes, I am. Okay, can you?
Yes, I can stop sharing.
Thank you.
I had my time already.
Okay. You can hear me loud and clear, right?
Yeah.
Okay, perfect. So let's take our cell phones. Let's put Kahoot.it and enter this pin code that we can see. the quiz is not going to be very hard. I mean, I have tried myself a couple of times, and it's just basic IT knowledge. Well, I wouldn't say that mainly IT, but basic knowledge that is going to be required. So we are waiting for a few seconds for everyone to join. The code is 3875946, and you all know how to play it. And well, you'll have to see my screen because I have tried to read it very fast, but you know, sometimes you just need to see the colors and you just need to press the right color that you think it is. So we are still waiting for. Okay, I think we can start. What do you think?
Let's wait 10 more seconds.
Okay.
I think
Maybe while waiting, I can tell you that I still remember one of the first build stuffs in Ukraine, in Kiev. It was like, I don't know, 8 years ago. It was fantastic. And I hope we can come back to these old times and meet in real.
Anton, we are sharing the first thoughts. Very nice that you said that. It was actually my first time as a host last year at the Virtual Build Stuff conference, and I do feel you because I have the best feeling ever when we have had such a great team there going on. And so thank you for sharing. And maybe we can start to play. Okay, so let's start. So the first question is, how many programming languages are there? So as we know, so red is 163, blue is 360, yellow is 150, and green is 700. Okay, we have, okay, so let's go to the next question. As we know, in the world, I think we have 7,000 languages, right? So let's move on to the next question. And we have Mantas. Mante, applause. Question number 2. In which movie does Robert De Niro famously says, you talking to me? So please, guys, just look at the colors if you can see them. All of this is okay. So the answer is Taxi Driver. Sorry, I didn't make it very fast because it was like a lot of things on my screen. Okay, Brent. Now you are up first. Okay, I will try to make it faster. I did it many times, but you see, it's not that. Okay, so what is the origin story of Python programming language's name? An inventor was bitten by a very angry python. This is a red. Blue, it was called after TV shows Monty Python Flying Circus. Green one is it sounded good. And okay. Let's move on. I will not read the answer, so please, if you could look at the colors because it's very fast. Jonathan, congrats. In the Matrix, which pill does Neo take? There were 2 pills. Okay, let's move on. Jonathan, good job. And which of these is most similar to a computer program? Is it science book, a blueprint, encyclopedia, or maybe a pancake recipe? Okay, Jonathan, good job. Finish the most famous quote of the movie Apocalypse Now. I love the smell of what in the morning? Muffins, gasoline, napalm, coffee. Okay, Jonathan. Okay, we have a seventh question. Who was the first programmer in the world? Was it Albert Einstein? Was it Ada Lovelace? Was it Ricky Ricardo or Peter Quill? The lovely females, right? No, I'm just... Woohoo. Okay, Jonathan. Good job. And number 8. What's Grady Brooks known for? This is the guy from Texas who's actually, I think, 7 years younger than Whitney Houston. So, and you know, winning a singing competition against Whitney Houston, that would be a good deal. Okay, so what I would like to say about Grady Brook that he has actually agreed to be as a speaker for next year's conference. So this is a very, very good job because I know that Build Stuff team was pursuing him for 5 years. So he finally agreed. So that is a very, very good thing. Let's move on to the next question. And we have the ultimate winner, Jonathan, so far. The 9th question. How many cameos does Stan Lee have in the Marvel Universe movies? 1, 52, 60, or 19? We have 5, 4, 3, 2, 1. Let's see. Yay, Helena, you came on the 4th place. Jonathan, again, congratulations. Brent, you have a 2nd place, and Oswaldus, you have the 3rd place. Let's go. The 10th question. What would a computer do without any programmer? Would it do nothing? Sing, show, tune, do math, or display images? 7 seconds. I would go for singing. Definitely. Okay. Okay, we have Jonathan on the 1st place, Brand and Oswald sharing 2nd and 3rd place. And the last question, true or false? The unicorn is the national animal of Scotland. Is that true or false? Three, 2, 1. Yay. And we have the winners. 3rd place goes to Brand. Woo! Oswaldus, you have managed to go to the 2nd place. And Jonathan, congratulations. And Philip and Helen are sharing 4th and 5th place. So thank you very much for playing. And I will stop my screen share and we will move on to Neringa, I guess.
That's right. So thank you, Vaida, for sharing. So winners, congratulations to you, and please send me your emails that I can contact you. I pointed in chat my email. And now, Sam, are you here somewhere in the crowd?
I am. Yes, I'm here. Hello, everybody. How are you?
Hello.
How are you, Neringa? How are you doing? How's all the team?
Amazing. Amazing. Stuck at home?
Yeah, well, I didn't like to say anything, but I am stuck at home as well. We're having weird weather where it's lovely sunshine and then it rains, then we get some hail, then some snow, then it goes back to sun again. So being stuck indoors is sort of okay at the moment, but you know, you've got to hope for better weather soon.
Yeah, that's right. That's right. Next week, I think will be amazing here.
Well, yes. I'm just thinking, I'm already looking ahead to next summer now for, you know, when I might actually get to go on holiday somewhere. But you never know. You never know. September might bring better things. So should I get going on my presentation?
Yeah, so we just did a short introduction. And Sam, thank you for joining us at this virtual meetup. I hope, like every time I see you, I say, I hope soon we will be able to meet in person.
Yes.
So I see that. But since we have what we have, yes, it's amazing that you are spending your time and coming to our virtual meetup. And I know that you was working a lot today and you just ran from one meeting to another meeting.
Yeah, it's just to give people a peek behind the curtain. I'm in the process of finishing off my a second edition of my book, Building Microservices, and so I'm setting aside big blocks of days for just doing writing, which means all my other work gets squished into a day. So yeah, I've had back-to-back things, but I got a 10-minute break. I just did 4 hours, a 4-hour session with some people in the US. But I got a 10-minute break, and I'm here now. I'm energized. I've had too much coffee. I will not sleep tonight, but more to the point, I will at least be awake and alert for this presentation and the Q&A afterwards. So yeah, thanks for having me, Neringa. I'm always happy to help out. And I always get great questions on these with the build stuff things anyway. So I kind of like that because it's like people are they're all quite switched on. They're going for the kind of those deep technical type issues. So I think I always really enjoy these presentations for that purpose. Shall I go ahead and share my screen and
Yeah, of course.
Okay, I'm just going to go and close down all my other things.
I see there are some people typing that this is my first attempt at microservice architecture. So Oswald, perhaps, well, it will be the last, and you will stay here. So,
yeah, well, it's really interesting because it's such a, people look at it and think, oh, that looks really cool. And then when you get to grips with all this stuff, and it's just, there's so many horrible things associated with microservices. And we're going to talk about some of them in the talk today. So let me just share my screen. And, oh, I don't seem to be, you might need to make me co-host.
That's right, doing that right now.
There we go. Fantastic. Thank you so much. Okay, right. Let's get going. There we go. So the presentation today is, well, it's microservice decomposition patterns. And I'm going to skip over a little bit of the content because I want to spend a bit more time on some of the more interesting technical aspects of this. But this talk is all about looking at the aspects of microservice architectures that, well, most people don't start with a blank sheet of paper. Most people have an existing system. And so the idea of, oh, I'm just going to build a new microservice architecture overnight is kind of pie in the sky. It's not how the world works. Most of us work with taking an existing thing that we've got and changing it in some way, shape, or form to do something else. And this talk is really all about how would you take an existing architecture, an existing maybe monolithic architecture, and move it towards a microservice architecture. And so I'm just going to give you like a little bit of some insights into how I think about this sort of work. And I'm really just going to jump us in at the deep end to an extent. But I need to pause the brakes just for a moment, right? So we're thinking about these lovely microservices, okay? And we think about, okay, here I've got a lovely architecture and I've got this sort of independent deployability aspect where I can make a change to one microservice and redeploy it, and that's all great. Well, it's fantastic, right? When you get a microservice architecture like this, where you can do that sort of hot deployment of your units, and the world's a happy place. But most of us don't start here. Most of us start somewhere else. Most of us have an existing system that doesn't work in that way. And you know, this talk is microservice decomposition patterns, but we're often talking about microservice decomposition from the point of view of starting with a monolithic system. Now, I think the monoliths get a lot of bad press. I think monolithic architecture is not inherently bad. I think, in fact, a monolithic architecture is probably the most default sensible approach for system architecture. If you don't know any better, probably stick with a monolith and you'll be safer. But monoliths do come in lots of different shapes and sizes, and it's probably worth talking about that very, very briefly. If we think about microservices, as a monolithic architecture, the way I describe it, at least, I talk about a monolith as a unit of deployment. So if all of my system is deployed as one unit, it is a monolithic system. And maybe the kind of almost canonical version of a monolithic architecture we might have in our heads would be the single process monolith. So all of my code is packaged together into a single process. So all my data is there in one big process, right? And so when I deploy, all that code gets deployed as a single unit. I then have all my data in a single database. And this is, as I say, this is not a bad starting point when you don't know anything else, as in you don't know what your system needs. Even me, as somebody who knows how to build microservice architecture, if I was building a brand new system, I may well start with something like this until I know better, until I know what scale my system might need, or where those boundaries are going to be to create those stable boundaries. We can obviously though have variations on this modular, on this monolithic architecture, and we can think of the modular monolith. And here's a situation where we've broken the code down into modules. So now, although we deploy a single process, we've broken it apart. So, you know, we can have one team working on one module, a different team working on module E. So we get a degree here of independent development, even though the act of deployment still requires coordination between those teams. We have to statically link that unit together and deploy it. Now, this, I think, is a highly underrated option, and many people would be much better off having a modular monolithic architecture rather than going all the way to a microservice architecture. Now, the reality is that we've kind of, you know, when we had mainframe-based systems, we could fairly reliably hot deploy modules. We've sort of lost that a little bit with many of our modern runtimes. Bits of this are possible with things like OSGI, for example, but not really in the way that you want to do things like zero downtime deployments. You know, look at the Erlang Beam VM is a much better example of a modern runtime, which would allow you to hot swap modules without taking the process down. Maybe in the future, we'll have more access to things like this, but right now our present is, if we want that independent deployability and that hot swapping, we're talking about separate services being deployed. But nonetheless, maybe we'll come back to this modular monolith as being more common, a more common approach for us over time. There are weird variations on this. We can do things like this, where we've actually got our data now living in different databases for these modules. And this looks like an odd architecture to pick, but this is a sort of what I consider to be a hedging architecture. If I'm working with organizations, maybe a startup, a company creating a brand new product, for example, and they're thinking, well, I think I'm going to have like 3 or 4 microservices. And I'm like, well, look, if we're not sure, let's keep everything inside one process. And so make it less distributed, right? So all the communication is then going to be over sort of within that process. Much faster, more efficient, easier to refactor across these boundaries as well than it is to refactor across a service boundary. But we'll actually start off by keeping the data separate. And the reason for that is that would then make further decomposition to microservices later on much easier, because these things are self-contained from the beginning. So that's something I might consider for a startup, where I really think I want to separate, I don't know, order microservice. Okay, well, let's create an order module up front and keep the order data separate, and that will make our decomposition later on easier. We're paying a bit of cost now in the hope that it saves us money later on. This is the definition of hedging. So, you know, that's a kind of monolith that I've seen use of before. We have our third-party monolithic applications. These are applications that might be written by third parties. I mean, think about, you know, CRM type systems or ERP systems like SAP. You might have SaaS-based products, content management systems that like Adobe Experience Manager. But, you know, these kind of big monolithic pieces of software that are made and managed by third parties often. You might be able to configure that and put some of your own functionality inside that system, but inherently there's limits to what you can do to change that system. And yet they are, to all intents and purposes, a monolithic application. You've got limited ability to make changes to it. So extraction or migrating functionality from a third-party system to a microservice architecture seems like a bit of a pipe dream. But it turns out that we can actually still achieve this. We have things, if we can access the underlying database, or if we can access things like the API layer, we have some ability to actually use migration patterns like the Strangler Fig application pattern, which we'll talk about later, to move to a microservice architecture. We've then got the dreaded distributed monolith. And as I said, a monolith, at least in terms of how I describe it, is a unit of deployment. And a distributed monolith is where you've got a distributed services architecture that you always have to deploy as a single unit. So you do like a lockstep deployment of the whole system. And these systems are a nightmare to work with because they have all the downsides of being a monolith. We don't have independent deployability, but they also have all of the downsides that microservices have in terms of being inherently a distributed system. And what you often find with distributed monoliths is you pay all the cost of distribution without getting anywhere near as many of the benefits as you might otherwise like, because you've increased the ownership cost of this quite significantly, because now your deployment activities end up being like massive coordination efforts. Managing lockstep deployments across multiple teams and multiple services is really, really painful. And sometimes distributed monoliths can emerge because, well, you've just got your service boundaries in the wrong place. You constantly find yourself having to make changes across loads of services and therefore have to roll those services out together. So maybe you've just got to be thinking, and this happens a lot with layered architectures. So you look at things like 3-tiered architecture, paste-layered architecture, all this rubbish around bimodal IT is basically all about layering of systems, horizontal layered architectures. But features always cut across layers. So if you're building a layered architecture, you're always going to have cross-cutting changes, and you're always going to have this coordination effort. With microservices, we're trying to think more about, end-to-end vertical slices of functionality. So we're not layering, we're kind of, slicing in a different way. So if this is happening to you a lot, if you're always making changes across service boundaries, chances are your boundaries are in the wrong place. You might be sleepwalking into being a distributed monolith and all of the associated pain that this causes, right? Much higher cost of change, larger scope deployments, more to go wrong, higher release coordination. Another possibility is the reason you've ended up with a distributed monolith is because you're using something like Safe. And Safe, for many, many years, codified the release train as being the ultimate way of deploying software. Now, the release train is a useful mechanism for improving your release cadence, but some organizations practice the release train at an architectural level. They'll say, okay, every 4 weeks, anything that's ready goes into production, and they're doing that across multiple services. And that codifies the idea that you're releasing multiple microservices together. So if you are in a situation where you're making use of something like the release train, practice the release train on a microservice by microservice basis. And remember that, that things like the release train are supposed to be training wheels. It's something you move beyond in order to help you embrace proper continuous delivery, which is unfortunately something that a lot of the Safe people missed, right? Release trains were only ever a remedial training technique, effectively, something you're supposed to move beyond. But there is a danger, though, if you have that release train mechanism for too long, you'll end up with the distributed monolith, and you may well find that you're not getting the best bang for your buck. What we're aiming for really is kind of moving towards true continuous delivery, which is fundamentally a release on demand approach. And microservices are heavily influenced by continuous delivery. In fact, they're the reason I got into them. Microservices are an architecture which is all about making continuous delivery as easy as possible. And this is partly through this idea of independent deployability. I can make a change to a microservice and deploy it, and the world is a happy place. So we've talked about monoliths, but we should also remember that the monolith is not the enemy. Monoliths aren't inherently bad. People have started to do this thing where they've taken the word monolith and used it to replace what the other word we used to use, which was legacy. And there's this idea that the monolith is bad, it's old, it can't be easy to work. No, there are loads of monolithic systems that are fantastic, that work really, really well, that are a perfect fit for organizations. We're in danger, though, of saying monolith equals bad. So whenever we see a monolithic architecture, we assume you have to get rid of it. And that's not the case. A lot of the time, it is a perfectly sensible choice. And microservices bring a lot of baggage with them. They bring a lot of complexity. So you should not make microservices your default choice. When I work with clients, they say, should we use microservices? My default position is not to use them. And I have to be convinced that they're a good idea based on what people are trying to do. And that's what you've got to remember when you're thinking about migration to a microservice architecture. What you mustn't lose sight of is what is it you're trying to do. Don't confuse activity with outcome. What do I mean by that? Well, a lot of people get consumed by the activity of creating microservices. Guess what? No one cares. Your boss doesn't and shouldn't care about microservices. The users of your software do not care about microservices any more than they care if your program is written in C++ or Python. They couldn't give a crap. What they care about is, does it work? Is it fast? Is it nice to use? Does it make my life easier? Microservices to them are an unimportant implementation detail. You've got to view microservices as a means to an end. They're a decision, a choice you'll make about your system architecture that you think is going to help you achieve something that you couldn't otherwise achieve with your current system architecture. And what problems you're trying to solve is going to drive which microservices you want to create and which pieces of functionality you extract first. It's also going to drive, like, how far do you go with this? People often ask me, how many microservices should I have? And it's like, well, I don't know. What problems have you got? When you're starting out on this journey, you want to be very clear. What is my goal? Okay, I've got to solve this problem. Okay, how can I solve that problem? Well, let's try all the easy stuff first. Well, we've tried all the easy stuff. We're left with microservices. Okay, well, let's try microservices. Okay, well, which microservice should we start with? Well, what's our problem? We can't scale the application. Okay, well, then, let's extract some functionality, which is the bottleneck. We'll move that into a microservice. We'll scale that independently. So straight away, the goal, needing to scale our application, is helping drivers towards which microservice we'd start with. So if you don't know where to start and you don't know which microservice to start with, that's often a sign that you don't know why you're doing the work. If you have a clear understanding about what you're trying to achieve, it becomes really easy actually to find out what your first microservice should be. And so then you start with the first thing. You create your first microservice and then you add another one and then you add a couple more. And all the time, as you turn that dial up, as you add the number of microservices you've got and you add a couple more, you're looking to say, am I making this system better? Am I getting the system to scale the way I need it to? Am I enabling my organization to scale up the way I want it to? And as you're turning that dial up and adding more microservices, you get the ability to say, hang on a minute, that's been a disaster. Let's back that off a bit. We've now starting to hit issues around, understanding what's going on. So we need to reduce the number of microservices or whatever we've got. This is not a static number, right? You're slowly increasing the number of things you've got. You're adding new things. You're assessing the impact. You're learning as you go, and you get to change your mind. You get to merge things back together again if they're not working out for you. Speaking about the problems of microservices, and I could do a whole day just talking to you about all the things that are bad about microservices. And in fact, if you come to the workshop, that's pretty much what we do. A large amount of the problems associated with microservices are not really going to hit you until you're in production. You're not going to appreciate the true horror, pain, and suffering of a microservice architecture until you're in prod. Lots of the issues are theoretical issues that may occur. You might be able to spot them around a whiteboard or on your laptop, but until you're in prod, it's all a guessing game. What this means is you need to get into production as quickly as possible to understand if this is a good idea. Start with one microservice. Extract that microservice, get it into production, get it integrated with your monolith, learn from that experience, and decide where you go from there. This is all about an incremental migrationary approach, right? To paraphrase Martin Fowler, if you do a big bang rewrite, the only thing you're certain of is a big bang. Now, I like explosions in my action films. I don't like explosions and big bangs in my IT projects. This should be an evolutionary approach. Do some prioritization, pick the microservice you think is the best one to do, create it, deploy it, integrate it, see if it works, learn from that, do a bit more planning, do a bit more building. That's what we're doing. It therefore follows then that we need architectural patterns that allow for incremental change. So we're looking really for patterns that allow us to change the structure of our system in a way which is safe, that allows us to manage that risk, but it also accepts the truth that your new microservice is going to need to coexist alongside your old monolithic system during this transition period. And remember that any migration is not necessarily going to get rid of the monolith. It's just going to change the monolith enough that you can solve your problems. And most microservice migrations I work on, the monolith never actually dies. All that happens is they move enough functionality out of it to solve the problems they've got. So one of the most useful patterns that you'll see used time and time again is a pattern called the STRANGLER fig pattern. And the way this pattern works is that you wrap a new system around the old, and it's inspired by a type of plant. This is actually a type of fig tree found mostly in Australia, but also the Everglades in Florida. So this fig has evolved to wrap itself around an existing structure. Without an existing structure, an existing tree, it couldn't survive and grow. Over time, as it becomes stronger, the new fig tree can stand by itself and it no longer needs the support of the underlying tree. And this is the same pattern, the same concept in software. We take the existing system, we don't change the existing system necessarily, but we wrap it with the new one. When a call comes in for a piece of functionality, we intercept that call. If that call is for the new functionality that we've migrated, we divert it accordingly. If it's for the old functionality that we haven't yet migrated, we allow that call to carry on to the monolithic system. The new system doesn't need to completely replace the old. It can just replace a bit. It can replace 1% of the functionality. And then over time, 2 and 3, and you can wrap more and more and more around it. And eventually you might get to the point where you've replaced all the functionality and then you can retire the old system. Fundamentally though, this works on intercepting calls using whatever approach makes the most sense for the way your application is built. You intercept calls on the perimeter of the old system and divert those calls to where that functionality is located. Now, let's talk actually about an example implementation of the STRANGLER pattern. Here's an existing monolithic application. And in this example, we're assuming that this application is being driven via some kind of HTTP-based API. And the reason I'm picking HTTP is just because it's very amenable to being intercepted and redirected in a way that's transparent to the consumers, the clients. So this could be a headless application. This could be an application where you're intercepting these HTTP calls underneath the UI. You should also break apart the UI layer as well, but this would start at least that decomposition in the services tier. So you've got calls coming into our existing system. So what we need to be able to do is we need to be able to intercept calls. So the very first thing we're going to do is we're going to drop a proxy in place. And the proxy is going to sit between the upstream and the downstream traffic. And this is going to be the thing we're going to use to divert the calls when we're ready. But right now, we're not actually doing any diversion. We're just allowing those calls to continue to the monolith. You would roll that proxy change out and you would deploy it to production. Why? To check it works. One of the secrets about releasing frequently is you make each release really small. A really small release is a safe release. If you release often, you get fast feedback about, is my software working well? So you want to get in the practice of releasing early and often. What are the things that we might be worried about by just putting a proxy in place like this? Well, firstly, does it actually work? Is it even able to do, is it even able to work properly? Secondly, what kind of overhead have we got here? You know, we've added a set of network hops and this is going to have some kind of load it's going to put. So there might be an increase in latency. Is that latency increase noticeable? Probably not, but it'd be good to find out. If you discover that adding a network hop or going through the proxy layer of your choice adds like 200 milliseconds of latency, then you probably want to stop right now and find out what the hell's going on before you go any further. So get that proxy deployed. Don't do anything else. Next, start working on your brand new piece of functionality. So we've taken some functionality from here and we're going to create a new microservice to implement that functionality. Straightforward enough, right? Now that microservice that you're creating that's going to say take over order placement or invoice processing, it's not going to be ready overnight. It's going to take you days, weeks to work on, maybe to implement, but deploy it from day one. Deploy your microservice, your new order placement microservice, your new invoicing microservice, deploy it into production the moment you've got a basic skeleton up and running. And it might just respond with not implemented error whenever it's called. That's absolutely fine. Get it deployed into production. But Sam, you'll say, it's not working. So how is that safe? We have to separate in our minds the concept of deployment and the concept of release. They are two discrete activities. We sometimes conflate them, but they are separate. The act of deploying software into a production environment is not the same as releasing it. If I deploy that microservice, but no one can call it, it is deployed, it is not released. The proxy is diverting no calls to it, so no one can reach it. So I can deploy that microservice. I can make sure that it's logging in the places I expect, make sure it's turning up in my dashboards. I can practice the deployment mechanism, make sure the right number of instances are being spun up. And I can iterate on that microservice over days, weeks. Once I'm happy, I've implemented all of the invoicing functionality. All I need to do to release this microservice is to just change the proxy configuration. That's the release. Just one proxy configuration change. If I hit a problem, I've got a rollback. What's the rollback? Oh, look. As part of this process, you'd leave the old functionality inside the monolith as well. That gives you a nice rollback point. It also means you can do things like canary releases and parallel runs, which we could talk about another time. So that, in a nutshell, is the Strangler Fig pattern. Intercept, divert. This is doing it with a HTTP-based proxy. A couple of things. Firstly, this is only going to work with things that are towards the top of your call stack. So say for an e-commerce system, something that's like checking the price of a catalog item or, placing an order, things where you're getting those calls coming straight from the UI layer. Those are good candidates to be intercepted and diverted as part of a Strangler Fig pattern. It's not going to be very useful to things that are kind of side effect based. For example, if as part of placing an order, you also send an order placement email, well, that's going to be difficult, right? Because you don't have a call that comes into the monolith that says, send email. What you have is a call that comes in as place order, and as a side effect of placing order, you send an email. So getting and extracting that functionality, moving that piece of functionality around, say, customer notifications into a separate microservice, that's not going to work with something like Strangler Fig pattern. But there is another pattern that we would use called the branch by abstraction pattern, and we go through that in the workshop. Or you can read my book, Monolith to Microservices. There's another thing is, I've talked about this as using HTTP-based proxy, and this would be fine if you're building a HTTP-based system, but what if you're not? And that's okay. I've used a Strangler Fig pattern. I've done this. It's any system whereby you can intercept and redirect calls. So I spoke to a company called Homegate based in Switzerland, in Zurich, and they're a real estate company, Homegate, and they actually used, they basically implemented a Strangler pattern using FTP. So their consumers, they're basically customers, uploaded data via an FTP interface. So they basically created an FTP interceptor. I've implemented a Strangler pattern using a message interceptor. So it's a messaging-based system. So we consume events on a message queue. And that's how the old system works. For the new system, we just stuck another queue in front. We intercepted all those events first. We siphoned off the events that we would handle and allowed the rest to proceed on to the downstream system. So it's any technology that allows you to do interception works. And you can also do this in the UI layer. I did this at the Guardian website where we basically intercepted at the templating layer a component and replaced it with the alternative component. And that allows us to incrementally change a UI. So the core concept is the same. So that is an example of a pattern which allows us to incrementally change the kind of our monolithic system without actually ever having to touch the monolith. That's all the beauty of this particular pattern. At no point here have we had to change the monolith. So this Strangler Fig pattern works really well with third-party software, COTS-based software, because you don't have to change the underlying monolith to do this to make this work. And that can be really beneficial in a lot of situations. I've used this for migrating away from Salesforce. It was Salesforce. I think it also helped out in doing one with PeopleSoft, but I think I blacked that out. So yeah, the other pattern that's kind of useful in this space is the branch by abstraction pattern. You can read up about that pattern separately. It's also in the Monolith to Microservices book. That'll be another pattern that you would use for things that are kind of inside that code base. So let's talk a little bit though about data. What do we do about data? Well, look, if we're pulling our code out of our system, we've also got to pull the data out as well. Remember, our microservices are self-contained. They want to have both the code and the data associated with our processes. So we need them both together. So the branch by abstraction pattern, the Strangler Fig pattern can be useful for getting the code out, but we've got to pull the data apart. And that's where things get really tricky. Let's take a look at an example and the kind of complexity you might have to deal with in this situation. So here I've got a microservice which is like an e-commerce system. This is an e-commerce system where we're actually selling CDs online, compact discs online. So we've got functionality within our existing monolithic system related to kind of information about the items that we have for sale. This is our catalog related functionality. So we store the ID of the item, the name, and maybe the recommended retail price in a database table, in this case called line items. We have the finance related functionality inside our existing monolithic system. And this relates to, this sort of handles financial transactions. So when we sell an item, we store that in the finance sort of functionality, stores a record of that sale in a ledger table. So here I can see that we sold an item on the 14th of June. We sold it for €4.98. And then we see a link here to the item that was sold. So we see here, the item had the ID of 123. We can look up 123 in the line items table and see that that item was called Death Polka Volume 4, which, as you all know, is a growth industry death polka. So this is fine, very straightforward. One of the things we have to be able to do is to generate a list of the top 10 bestsellers. So I need to know that this week the bestseller was Death Polka Volume 4, then the greatest hits of Peter Andre, which seems inconceivable. And now that's what I call Hoover Core, right? Now to generate a simple top 10 listing like this is a very straightforward SQL query, right? All we would need to do is we'd go and pull back. We'd look at all the sales that were made in the last week, group them by the SKU column, count them up, order by the biggest number of SKUs. But then we'd need the name of the album, and the name of the album is not in this ledger table. So we're going to have to join. So we're going to have to do the join from here over to here, and that would get us the result. So effectively what we've got is although we think, okay, the line item is owned by the catalog functionality and the ledger is owned by the finance functionality, we've basically got a cross-cutting concern here in a way. This is a join relationship. And within a single monolithic system, talking to a single relational database, this is a completely sane and rational thing to do. And it's one of the reasons why relational databases are beautiful things. The problem, of course, is, well, in our situation, we want to make catalog and finance two separate microservices with two separate self-contained databases. So this join operation is verboten. We can't have it reaching directly into someone else's database to do a cross-database join like this. Effectively, what we end up doing is moving this join relationship up into the services tier, like this. So now what we're going to do, if we roll forward to our new microservices world, when the finance microservices said, what's the bestsellers this week? The finance microservice goes and fetches the top 10 IDs. So I'm going to go to the catalog microservices and say, can I have the record names? The catalog microservice is going to go to its database, pull that back, return the results, and that's where we are. Now, of course, straight away, this is going to be, from a latency point of view, not great. We will absolutely have increased the latency of this operation. And that's often the enemy when we're decomposing systems, is that we are increasing the latency of our systems. Now, that's unavoidable for some things. And sometimes latency increases are acceptable. It's always down to how much latency can you accommodate. You can effectively treat a latency budget like an error budget, if you will. Now, in this particular, and sometimes actually when you break microservice up, when you move towards microservice architectures, you can sometimes improve latency. This might be because you've reduced and removed sort of operational bottlenecks or infrastructural bottlenecks. It might be because you've created the opportunity for work to be done in parallel, thereby reducing the overall time an operation takes to complete. This is not one of those situations. Here we've basically got two kind of database round trips that cannot be done in parallel. They have to be done sequentially. Now, how do we make that faster? How do we solve this issue? It's caching, right? We won't go into caching today because that's something we spend like an hour on in the workshop. But caching would be the way you'd solve this particular problem in terms of how you make this fast. And, maybe some streaming queries over Kafka, but that's a different conversation. We're going to take a look at a different set of problems that this has caused. When we think about the relational database here, we have a relationship from the ledger to the line items table. And this relationship is called a foreign key relationship. And in relational databases, foreign key relationships are quite common, and they are awesome things to have, right? Foreign key relationships give us three primary things. The first thing they do is they enforce referential integrity. So if I try to delete, this item from the line items table, the database would stop me. The second thing they do is they make relationships explicit, and this is useful. We are saying this is related to that. That helps us better understand how a database hangs together and how things are connected. There's a great degree of, there's a huge benefit in making things explicit. And this is, you know, this is important stuff. It makes data models more meaningful. The third thing that from key relationships do that a lot of people forget is they make joins faster. How does that happen? Magic. It's not magic, but by telling the database these tables are related, the database gets to go, guess, okay, you're going to be doing some join operations, aren't you? I know. So then what it does is it generates a whole load of secondary indices to speed up the lookups. Even if you don't define from key relationships, if you join across the same values enough, the database will start doing some optimizations. But if you tell it they're related, it will do a lot more of those optimizations up front to make the joins faster. Now, with our microservice architecture, we aren't going to be able to do much around improving join performance unless we start looking at data duplication or caching. So again, we'll take that off topic to an extent. But we can at least today talk about these two things. How can we make the relationships explicit in our new microservices world? And how can we reinforce our referential integrity? Well, making things explicit, there's some easy answers here. This is a scheme I quite like. This is from this is an example of what they did at SoundCloud. So they came up with a scheme to make cross-service relationships much more explicit. The idea being that when I encountered an ID in my database, it'd be very clear to me that this is actually pointing to something that's elsewhere. So they came up with a scheme which was SoundCloud : name of entity : ID. So if I found an identifier that said SoundCloud : tracks : 123, I would know that that ID related to a track. And actually, they created a library that could take those URIs, those pseudo URIs, and convert that to a lookup. Otherwise, I'm just fine. Okay, well, that column contains 9515112. What does that relate to? I'm going to have to look at the code to see how we use that ID. Oh, it seems to be doing a lookup on this microservice. Oh, okay, so it must be a relationship. Whereas with this scheme, it's explicit the moment I see it. And that explicitness allowed SoundCloud to actually create a library to do those lookups. Very, very cool. Obviously, if you're building an entirely REST-based system, you could just directly insert URIs. But this SoundCloud were using an RPC framework based on Finagle. So for them, this is a different scheme. But I really like it. And this is a really well written article by Phil that goes through all the pros and cons of this approach. But what about the referential integrity? Well, the problem we've got here is that if I delete an item, we break that relationship. So what are our options? Well, look, to be honest with you, part of it is kind of just suck it up. You lose things by breaking databases apart. And there's an extent to which you now no longer have enforcement of data integrity-ish. When you have the database enforcing referential integrity, you're using the database's enforcement sort of like a safety net. You're still going to try and do things in your application tier to stop your data model integrity being broken. And what happens is if your application tier doesn't deal with that, then your data tier will catch you. We've just lost the safety net, but we can still do things inside our application tier if we want to. But there are still other options available to us to deal with this particular situation. One of these is just, well, why not just do a shadow delete or soft delete? So in this example here, I don't actually delete the row from the catalog table. What I instead do is I add a new status column. And so when I delete the item, I actually just mark it as deleted. What this basically means is that my reference can still work. So my system will still keep operating. A variation on this never delete model would be to say, okay, well, what if this was an event store system? With an event store system, I never actually delete anything. And so those references can always be maintained. Now, as probably, especially at build stuff, I don't have to downplay the complexity of making event sourcing work well. If the only reason you are implementing event sourcing was to solve this particular problem, I would say it's overkill of the largest order. That said, if you had implemented event sourcing, this problem kind of goes away because you're not going to lose these references in that way. But, a quick win may be a soft delete, right, in the short term. And that's probably one of the easier things to do. Now, of course, what you'd have to do is to change some code elsewhere, because if deletion was normally part of your normal operating procedures and it happened quite a bit, then you're now going to have to change places, parts of your system. So maybe you're going to have to change your web interface to filter out anything with status deleted. Whereas in the past, they could rely on them just not seeing those records in the first place. So just dropping in a status column, you're going to have to do additional work to filter that out for the rest of your system. So it's not a perfect solution, but it's something. What else could we do to deal with this situation where we might lose information if that line item was deleted? Well, we could copy data. So in this example here, when we've inserted a row into the ledger table like this, we've also taken the name of the album that we sold. So now suddenly to do what's our top 10 bestsellers, all the data we need is available to us in that ledger table. Fantastic. That solved all of our problems. We're now even reduced a whole bunch of service calls, and it's faster as well. Why shouldn't we always do this? Well, what if it changes? When you duplicate data, you've got to ask yourself the question as to why are you doing it? And really importantly, what do you expect will happen when the source data changes? Because we have to accept that this is the source of truth of what this album is called. If you copy that data locally, which you might do for performance reasons, what do you think should happen when the name changes? If you think this should update, then you're going to have to build some kind of invalidation mechanism in place to allow that to be updated. And that's adding more complexity to your system. And again, that might be more work than is warranted, especially if there's other data you end up needing to insert. On the other hand, if you don't expect for it to change, so in other words, the reason you're copying it is maybe more of an historic record. So maybe what you want is, I want to know what that album was called when we sold it. The fact that you then change the name afterwards doesn't matter to me. I want to know what it was at that moment in time when that order was placed. I'm copying it more as an historic record. In that situation, I don't want Death Polka Volume 4 to become Death Polka Volume 5 when someone fixes it here. And in that situation, copying the data is really straightforward. You're not worried about invalidation. You just have to accept that that is not the name of the album now. That is the name of the album as it was when we sold it. So this is not the source of truth. This is what Pat Helen would call a memory. And it might be a false memory. But nonetheless, that could solve our problem. No joins needed, no round trips. Could be a nice, easy solution. But you got to think, what do I do if the data changes? Here's another option. Why don't we check to see if the item is being used before we delete? Well, this is easy, right? Oh, no, this is awful. Don't do this, but let's explain why. Here's a catalog, right? And we want to delete an item from the catalog. And the catalog knows, well, I don't want to cause any inconsistency in my data model. So I'm going to check to make sure that nobody has got a reference on item 123, Death Polka Volume 4. Because ultimately, a relational database does this. When you try and delete it, it checks. Now, if someone's referencing it, you can't delete it. So we're doing the same thing. We're moving that logic to our application tier like we did with the join. But it doesn't work very well. So I go to the catalog, so I say delete item 123. The catalog goes, okay, well, I need to check in with everybody else before I do this. So I'm going to go ask, in this case, the invoicing microservice. I say, hello, invoicing microservice. Have you got any references on on the catalog item 123? Invoice microservice checks its database, says, no, I don't have any references. And I'm getting some background noise from somebody. No, I don't see any references. Okay, in which case, you're free to delete. Great. Now, a couple of things about this kind of idea. Firstly, how does the catalog microservice know which other microservices to ask? Effectively, the catalog needs to be able to check in with any microservice in your architecture which could ever have a dependency on the catalog. So the catalog needs to know everyone that depends on it, and then needs to be able to ask those microservices, have you got this reference? This becomes effectively an explicit and required circular dependency between these things. And of course, there might be 50 microservices that rely on data in the catalog. So this is going to get, really problematic, right? I could work out ways to kind of design a protocol like this that wouldn't be as bad as this, but it's still not perfect. It wouldn't be very elegant, certainly. And look, is it even guaranteed to work? Well, as I've explained it so far, no, it's not. It's not guaranteed. Here's why. Let's start again. We go to the catalog microservice and we say, hello, catalog, can you please delete row 1, 2, 3? We don't need it anymore. We're not using def polka anymore. And the catalog service goes, okay, yeah, but I need to check in with my friends first. So it goes over to the finance microservice and says, hello, finance microservice, are you using row 1, 2, 3? And the finance microservice goes, I'm going to check my database. No, we're not using it at all. So you go ahead and delete it. Now, in that split second after we said, no, I'm definitely not using it, we sell an item with the ID of 1, 2, 3. We've now added that entry to our database, and then we do the deletion. That can happen. This is a multi-user system. This is a multi-process system. This thing's happening all the time. It's a small window, but it's a window nonetheless where this could happen. We check, it's not there. We tell them, they do the deletion, we add the entry. It can happen. Now, if you wanted to make sure this isn't possible, you would have to apply a lock. So when we go to the finance service and said, hello, are you using item 1, 2, 3? And we say, no, I'm not. I say, okay, great. Well, please place a lock on your system so that you're not able to sell an item with that ID. And I'm doing some cleanup. And when I've done it, I'm going to come back and tell you to remove that lock. So you place a lock here, which inherently would end up putting a lock on a table, right, or some way, shape, or form, to say, just don't do it. When we do the deletion, then we'd go back and remove that lock. So this sort of check before deletion gets us into the world of coordinating distributed locks. Now, locks are fun. Who doesn't like a lock? We've all probably had issues with dealing with deadlocks within a single process system. The kinds of slowdowns in our system performance that can cause, and dealing with a deadlock in a single process system is fun. Imagine dealing with a distributed deadlock. That's, yeah, delightful. And this is partly why things like Zookeeper were actually created, was to aid the coordination of distributed locks. Although nowadays you wouldn't use Zookeeper for this sort of thing. So this is not great, and it's complicated enough that I've never actually been in a situation where I've tried doing this. So I would always look at one of the alternative approaches. Now, one of the other things that we didn't touch on, I'll mention just before the end, is one of the nice benefits of sort of the foreign key relationship is it can not just enforce our data integrity, but it can also allow to implement things like cascading deletes. And they can be really useful. Imagine a situation where you need to delete all the information about a customer, for example, as part of, I don't know, GDPR. You would be able to delete that customer and make a cascading delete, which would follow all the dependencies and remove those as well. I mean, obviously, just think it through, but it's a possibility. How do we do that sort of thing in a microservice architecture? Well, this is where events come into play. So I say to the catalog, please delete item 1, 2, 3, and we delete that item. And then we fire an event. Now, remember, with event-based interactions and collaborations, an event is not a statement to do something. An event is merely a fact. This thing has happened, and I'm letting you know. It is up to the recipient of the event what they do with that information. In this situation here, the invoicing microservice, maybe it's maintaining a local cache of catalog entries, gets the event that says, oh, item 1, 2, 3 has been deleted. Well, based on my internal logic, I know that when that gets deleted, I should just remove my local references. And this effectively could allow you to implement something like a cascading delete. Now, the key thing here is it's up to the recipients of the event as to what they decide to do with it, right? So in this case, the invoice decides how to react to this. When it came to your finance microservice, you probably wouldn't want to delete an item from the ledger, right? Deleting items from financial ledgers is how you go to prison. In that situation, maybe the finance microservice says, oh, well, that item's been deleted from the catalog. Well, I still want to know what the name was of that album for reporting in the future. So at this point, I'm going to copy that data locally because, of course, the event could contain all the information about the album as to what it was when it was deleted. Also remember, events are lovely things, but they are not instantaneous. There will be a delay between the event being fired and us seeing that event. You know, event-based systems work in this way and end up inherently being eventually consistent in this way. So that was very much a whistle-stop tour through some nasty issues associated with data data decomposition, and some patterns around application decomposition. We also talked a little bit about how you prioritize that work and different types of monolithic systems. This is kind of just like a little overview, really, of some of the content that's both in the workshop, but also I think I've given you some really concrete things to get to grips with. Now, if you want to know more, I have also a book called Monolith to Microservices, which I've got a copy of over there. Look, you're going to forgive me, but I've got a mortgage to pay for. So here's the book. Look, right. So this goes into loads more details about how this particular stuff works. And I've got excruciating detail out there. If you don't want to pay any money to read the book and you want to read the book for free, you can get a free trial at o'reilly.com. I think it's either a 30-day or a 7-day free trial. And you can read my book for free and I get no money. While you're reading that book, just think of me sobbing at home and my starving children. My son's 21, he's fine, but just imagine I've got younger kids. Anyway, I hope you've enjoyed all that. Loads more information over my website, but I'm now happy to spend some time answering questions. So do we have some questions? We do. Okay, let's have a quick look. Okay. So, so here's a good question. Now, in advance, I'm going to apologize if I get anyone's name wrong. Okay, my pronunciation of names that aren't very Anglo-Saxon English is not great. I can do Irish names as well, but that's about it. Okay, so this is a question from Ritz. When you proxy the requests via that HTTP proxy, so coming back to that Strangler fig pattern, you need a good interface in the monolith before. I assume that's not the case in legacy monoliths. Should the interface be recreated in the monolith before being moved to the microservice? That's a really good question. So kind of an example of what Maurice is talking about here is that if you can clearly identify the inbound call as the thing you need to divert, your life is easy. So let's take the simplest example. You've extracted the invoicing functionality and the inbound calls all go to a URI path that goes, mycompany.com/invoicing. Well, that's nice and easy. I take that, I divert it. Nice and easy. Now let's imagine though that all of your API to the outside world goes through a single entry point. Do stuff.aspx ? And then a huge unintelligible query string that you somehow got to magically know what it means, to know what method is being called. In those situations, it's very difficult for you to take that inbound request and parse out of it what is trying to be done. And in that situation, it becomes quite painful to do the indirection there. Now, to Moritz's point, there's a couple of options you could do here. The first is to clean up the API in the monolith before doing the migration. And that can work, although often you're trying to migrate away from the monolithic system anyway. So the idea of putting a lot of work into modernize that monolith when you've already want to go and do your microservices anyway isn't always what people want. What you can then do is effectively do what I call subcutaneous strangling, which sounds much more violent than it is. But rather than that interceptor sitting outside the monolith, you have it set inside. So if I have one giant function interceptor that takes that entry point and then works out what it is and then calls my code path within my monolithic system, I could effectively put my interception inside the existing monolithic system. And so do that dispatch internally. So you've got two different options there, Moritz, as to how you'd handle that. You'd also say, if you look at it and you just say, look, I can't understand how intercepting this cause is even possible, you might just say, well, the Strangler fig pattern isn't a good fit for this particular problem space. Remember, patterns aren't universally good or bad. Grady will tell you this when you chat to Grady when he comes to build stuff. That's why I don't like using the term anti-patterns, right? A pattern which works really well in one context might be a bad idea in a different context. So, the Strangler fig pattern is one of the most universally useful migration patterns that I have used. There still have been lots of situations where it didn't quite fit. And that might be, if your situation is like this might be a problem for you.
Thank you. It's
any other question, Mitch?
And the name is totally fine.
Oh, yes. Thank you, Rex.
You're welcome.
So the next question here, now this is going to be more difficult for me, is Sahawi. Okay, I was close. Was I close?
Yeah, very close. Yes.
Okay, good.
Perfect.
But
Perfect.
I'll take that as a win. And so, yeah. I think you probably said it before I touched on it, but which was, what about a read-only replica of the catalog table in the finance service? It's totally a good idea, right? The key thing then is to ask that, is to deal with the invalidation. So really what you're doing here is you're kind of a cache, right? You could see, I mean, arguably any data replica is a subset of a concept of a cache, right? So you could have that copy locally. You just got to deal with the invalidation flows. So how do I update and how do I invalidate that data? And so that's the only real question in that particular use case. And obviously when there's actually, if you think about that replica is one way of doing it. You could also cache just the lookup table. You could stick with those proxies in the place. All of these things could speed that operation up. And a lot of it would, people sometimes, what would I do in this situation? A lot of it depends where my concern is around the bottlenecks, the performance bottlenecks. So if my concern around the performance bottlenecks was the fact that I had to continually call the catalog microservice, well, I could still cache actually on the server side inside the catalog microservice itself and serve everything out of memory. So there's variations, but yeah, it's a totally viable approach. The one thing I'll say about the kind of the way you phrase it, so let's have a table in my database. When you sort of say this is when you read something programmatically out of a cache and a developer is aware that they're doing that, they also tend to be aware that this data might be out of date. It might be stale. And you also kind of intrinsically know it's not your data, right? You've got a copy from somebody else. When you start replicating things into tables, though, inside your schema, it can often be a little less obvious to a developer that that's not your data and it might be out of date. So you might believe you're operating on the freshest, most up-to-date names of these things, but in reality, you're not. I have seen situations, and I've worked on a couple of systems like this, where tables like that started off being read-only copies. And then a year down the line, 2 years down the line, people started thinking it was a source of truth. And then they started making it read-write. And now you've got two different systems, both thinking they're maintaining the same names, even though in different places. And then you end up with two sources of truth. And it becomes a painful exercise. So if you are going to put it into a database table, like make it really explicit that it's not your table, maybe with some terminology or some naming of that table or something. That'd be a bit of advice there. So I hope does that kind of make sense, Zahawi?
Yeah, I think so. Yeah, we are kind of not fond of calling other services because it tends to get to a chain of calls that really is a pain in latency, performance, and also it couples services on a it kind of breaks the decoupling of the services. So we try to find another ways around that. A common issue we have is, for example, the user data. A lot of services need the user data for the operation. Who was ordering? Who did this operation? So we kind of moved on to event-based system on Kafka, which really works well for us.
Yeah. I mean, one of the really nice solutions, if you're using Kafka for this, is that this potentially can solve your caching problem as well in a really kind of a weird way, because with Kafka, you have the option of making your messages permanent. So basically, you could have the catalog microservice, in my use case. Anytime an entry changes in the catalog, it fires an event. But like a traditional message broker, events are kind of ephemeral. Once they've been consumed, they vanish. With Kafka, you've got the option of saying, no, that thing lives forever.
Yeah, this is exactly what we're doing. Yeah, we have this DB connector, MySQL DB connector, and Kafka, which basically every time a row changes in the database, an event is directly fired on the Kafka.
Yeah, so it's using, lots of people using Debezium for that, to get that stuff out. It's probably what you're using to actually get the events out from database changes. It's effectively a change data capture pattern. One of the interesting things, I don't know if you've looked at it, if you're using Kafka already and you're kind of treating your event stream that's coming out of Kafka effectively like an event-sourced queue, event store system in a way, is to have a look at KSQLDB if you haven't already looked at it. And that's a way you can actually define SQL-style queries across event streams and create things like materialized views. So
Yeah, we're getting into that.
It's super cool.
Building state machines on that and stuff like that. That's really, really powerful here.
It is. I mean, the only downside to it is you're very much all in on Kafka at that point, right? So you kind of, you're never moving away from it, which is, you know, it can be a downside. But yeah, it's great tech. So it's really useful stuff. So, okay. So somewhat related, actually, we had a question here. I'm jumping around a little bit just because we got a question here from Osvaldas, which is, once you've decomposed your data, any patterns for recomposing it back for things like OLAP? I mean, actually, Kafka and chain data capture patterns are a really good way of doing this. So a lot of this, though, I think there's some little devil in the detail stuff here. So chain data capture, pretty standard thing. I write into a database, and then a system captures that change and allows it to be broadcast. So in Zoe's case, it was about, you know, using Kafka to then populate that change. And I could obviously put that into, say, an OLAP cube or into a data warehouse or something like that. So that's a very common technique. A lot of the times I find with common sort of reporting cases or data warehousing use cases, a central team expects to go and grab the data directly from people's databases. With microservices, that becomes a bit more problematic because those schemas might be changing. So what I think it's better to do is to invert that ownership. It should be the responsibility of the microservice maintainer to make their data available for OLAP purposes. So if you've got like a data warehouse, for example, to solve that problem for you, or a data lake, it's the responsibility of the microservice owner to publish that data out in a timely fashion. And I think that's appropriate because ultimately the needs of a reporting stakeholder are the same as anyone else using a microservice. This also means as a developer on the microservice, if you choose to change your internal data store, it's up to you to reconfigure your change data capture pipeline. So that's exactly how I do it. So basically push the data out, use change data capture. You could just use other evented systems. I mean, using a data lake, lots of people like data lakes now. It's just, you know, I'm not entirely sure when a data lake is more than just JSON files in an Amazon S3 bucket, but that also seems to work really well for a lot of people. So just some quick tips there. So I hope that's kind of useful to you, Osvaldas. Here's a really good question from Marijas. Are circular dependencies an immediate red flag? No, they're not. Now, I called out the dependency with catalog always having to talk to people. So we don't like circular dependencies, right? Because they hurt our heads and they cause compilation issues sometimes. In general, we don't like circular dependencies for this reason. We like nice directed acyclical graphs. But as part of microservice decomposition, there are often situations where, you know what, some circular dependencies kind of have to be tolerated. Imagine a situation where I've extracted invoicing functionality from the monolithic system. So invoicing now lives in my invoicing microservice. The monolithic system wants to make use of invoicing, so it calls out to the invoicing microservice. That seems fine and appropriate. The invoicing microservices needs information about orders. The invoicing microservice doesn't own order information. The monolith does, so it has to go back to the monolithic system. So we might have a circular dependency there at short term as part of a decomposition. Now, for me, I see that as more of an interim state. I've got that right now because at the moment, the monolith is doing lots of things. Over time, I'm going to reduce what the monolith is doing. It might point me towards wanting to make the next thing I extract to be the order microservice to remove that circular dependency. So for me, I would describe circular dependencies not as a red flag, but maybe as a warm amber. So when I see a circular dependency, I'm like, I should look at what that is. Is it a problem? And then it might be cause for concern, but it's not an immediate red flag. So no, I hope that kind of makes sense. But honestly, from a logical point of view, the way you deal with circular dependencies is the same way as you always deal with them, which is you either merge things back together again or you split things apart. In the case where you're doing incremental decomposition from a monolith, there will be times when you have it. One little tip in that example where I'd split invoicing from the monolith, and I had invoicing calling back into the monolith to get the order information. From the point of view of the invoicing microservice, it should be talking to an order API, not the monolith, right? Because then from a logical point of view, it's unaware that it's talking to a monolithic system at all. It just so happens that the order API is currently provided by the monolithic system. And then at least logically, you don't see that circular dependency inside that invoicing microservice as much. So I hope that kind of makes sense. Next question. This is from MJD. Does a microservice always correspond to a single deployable unit? For example, could a shipping microservice be two distinct deployable units? If that's true, could they access and change the same database? Fantastic question. You're absolutely right. Yes, in general, a microservice, all the code associated with the microservice, you'd package together in a process and deploy that. And you kind of think about a microservice as a single unit of deployment, although the fact that you've probably got a database schema as well is, that's also arguably part of the deployment. But you're absolutely right. There are situations where your microservice process your microservice might need to be more than one process or different types of processes. Well, let's imagine you've made a decision to implement the CQRS pattern, for example. Now, I'm not a big fan of CQRS as a general purpose thing, but there are situations where it's warranted. In that case, I might have separate read and write processes. Now, logically, they're all still part of that same shipping microservice. I might still want to always deploy them together, but I might have multiple read processes and fewer write processes. Because they're all logically the same unit, they could also have access to the same database. Now, in that situation, I would probably version control them together as well. So in other words, when I always deploy one, I probably would deploy both. So there's sort of still, it's a single unit of deployment, even though that unit of deployment maybe has multiple processes associated with it. Another example of that might be if you had, say, a sidecar process that was responsible for doing your data pumps out to OLAP stores and things. That's going to be so tightly integrated with your internal data model that although it's a separate deployment unit, it's effectively still logically part of the same logically versioned artifact. So there's absolutely are good exceptions to that use case. It's more of a general point that there'd be a single process, but there are definitely variations. The key thing here is if you've decided to implement a single microservice as more than one type of process, that decision should be invisible to the outside world. So consumers of that microservice should not care that you've got read and write processes. That's an internal decision that you made, and that you might unmake that decision. You might merge them back together again. So when you're doing things like implementing, say, a CQRS pattern inside a service boundary, from a consumer point of view, that should be invisible to me. And so, if you can, as long as you can maintain that level of abstraction, you're not going to go far wrong. So any advice for how to solve a problem when developers move the code first and never move the data from the database because it's very hard? What you do is you buy lots and lots of copies of my book, and then you hit them with it. That's not very useful. Okay, a couple of things. Yeah, it is. It is hard. I think the first thing is to depends what kind of role you're in. I mean, if you're in a role of, architectural leadership or technical leadership, you've got to play the long game and see the problems this is going to cause and tell them, no, we're fixing this properly. There are other things you can do, though. So even if people accept, okay, well, look, we've done it now. We've got 15 microservices and all talking to the same database. We know it's not great, but we're not going to fix it now. Okay, fine. But what you can say is, well, let's at least not make it any worse. So the next time you need to store a piece of data, don't store it back in that same shared database. At least start creating separate databases for new data, right? So you can at least not make the situation any worse. Maybe you say you place an embargo. No new types of data can go in that database. Let's at least get good at storing isolated data for new things. And once you start seeing the benefit of that approach, it'll be much easier to come back and start to maybe chip away at that big shared database. Also, in some situations, the right answer is basically to wrap the database with effectively a service layer to solve some of these issues. I think I'll talk about that in a bit more detail in the book, but that's one other option. Okay. But yeah, I mean, lots of copies of my books is definitely the way to go. All right. Have you seen any successful examples of upfront service decomposition in greenfield projects? Well, decomposition implies you're breaking something apart, and in the greenfield projects, you don't have anything to break apart. So kind of no. I think what you're probably talking about, as well as is almost like upfront services design. I have seen some examples where it has worked. I've seen more where it's been problematic. The reasons why it's often problematic is with a greenfield project, you often don't know what it is you're building. Therefore, identifying stable service boundaries is difficult. And you often end up finding you're constantly refactoring across those boundaries, which is quite expensive. An example, though, where I have seen it work quite well is a company called Monzo. So Monzo are a fintech challenger bank based here in the UK. They got some flack because they had the temerity to share some information about their internal architecture. They said, we've got 1,500 microservices. And everyone says, you're an idiot. You're stupid. It doesn't work. And they're like, it kind of does work and our customers are happy. So it's like, you know, don't judge people based on how many microservices they do or don't have. It works for Monzo. They do some amazing stuff to make that stuff work. But they started off very early on with a services-based approach. And part of the reason they're able to do this is because they're operating in banking, a banking domain, which, you know, the domain of banking, certainly of their type of banking, is very well known. And in fact, a lot of the domain of banking is almost enshrined in how you go about doing your regulation and stuff like that, and your auditing and your oversights. So they working with people who knew banks and knew banking, and so they started off with services based around core banking concepts. And that stood them in good stead because that domain has been so stable and is so well known that it worked really well for them. So in that kind of situation, it was a good mix, but that's rare, that kind of circumstance. Okay, I don't know how much time I've got left for these things, Naringa, but I've got 2 more questions here. One from Jesper and one from Zawali. So I'm going to go with Jesper's one first. Oh, okay. This is a good question from Jesper. Would you consider changing the communication mechanism as part of splitting a monolith, as in from synchronous to asynchronous communication? I might consider it. I always like to phase it if possible. So what I would rather do would be to split the microservice off and still use the same communication mechanism initially, and then change the communication mechanism afterwards. The reason for that is if I can extract the functionality into a microservice, but have it be fairly comparable to how the old functionality works, it becomes easier to get a baseline. I'm also introducing less change with that. I might then move to asynchronous afterwards. Often changing to asynchronous communication is often going to require you to maybe change how the user interface works as well. One thing I have seen people doing as part of a Strangler Fig migration is using that proxy layer when you do the interception to also change the communication protocol at the same time in that proxy layer. And that could be a way to change your communication mechanism. I don't like doing that. It's effectively protocol rewriting. So you've got a call that comes in that's using the old synchronous HTTP thing. It hits your kind of abstraction layer and it goes to the monolith. And now it goes to your new microservice. And in your abstraction layer, which could be an API gateway or a hand-rolled proxy, you say, I'm going to take that SOAP call and I'm going to rewrite that as an asynchronous call in insert protocol X. The problem is when you do that protocol rewriting, it's always very specific to a specific microservice. And if you've got microservice specific functionality, put it in the microservice. Don't put it in these shared layers that become sources of contention. So in that situation, I might have a microservice that supports both the old synchronous REST-based interface, but also supports a brand new asynchronous interface. There's no reason why one microservice can't support more than one endpoint. And then the mapping between them can be done inside your service boundary. You can give consumers a time to migrate over, and then you can retire the old endpoint. It's all quite elegant. So there's a question here, when it comes to a distributed monolith, how would you slice things apart to prevent a distributed monolith? Good question. I didn't touch on that. If you've got a distributed monolith, one of the last things I'm going to do is create any more microservices, right? I'm not going to be slicing up anything right now. The first thing to do is to understand what is the cause of the coupling between things. What you'll start to look for is patterns. Do these 3 things always talk to each other? Are they always what changes together? So you're looking for identifying change coupling. So if you see like these 3 or 4 microservices always seem to get changed together, and that's what's causing part of this monolithic nature, then sometimes the answer is not to split things apart, but actually to merge things together. These 3 things always change at the same time. There's actually source code analysis tools, a good example that can help you spot these patterns. Code scene is a good example. It will tell you these bits of code always seem to change at the same time. They call it temporal coupling, which I don't think it's not how I define temporal coupling, but that's a separate conversation. So actually with a distributed monolith, I'm much more likely to merge things back together initially, before I'm going to add anything new. And if there are things that could be deployed independently, but just aren't, then I would get into the habit of doing that. So often this is more about behavioral changes as much as architectural changes. And I'd get these things working well. Now we are at time, and I don't want to keep you any longer because I know it's been a late night for those of you who are on EET versus GMT +1. So thank you so much. There's loads more information on my website. I'm just samnewman.io. I'm on Twitter as just @SamNewman. If you ping me questions on Twitter, I'm happy to answer them there as well. Naringa's shared a link to the workshop I'm doing, and there's a promo code there if you're able to come along. Love to see you there if you can make it. Otherwise, have a fantastic rest of your day. And thank you so much for coming along today. Thanks all.
Thank you very much.
Thank you, Sam.
Thank you
Well, I
so
see
much.
lots of
Thank you, bye.
thank you messages coming in. So that was amazing talk. Thank you everyone for joining.
It was
I
very
hope to see
awesome
you
to listen
soon.
to you, actually. You were very buzzing. It was really cool.
Well, it's partly because Naringa always puts on a good show, and so I always feel energized for these things coming in anyway. I've also had an epic quantity of caffeine. So, that's why I'm so chatty, but I'm glad you enjoyed it.
Yeah, it was really cool to listen to you, yeah.
Oh, great. All right, well, everyone have a great day, everyone. And I'm hopefully at some point in the future, we'll get to meet face-to-face at an in-person Build Stuff event.